Hello ladies and gentlemen, and welcome to your first video math lesson. Today we're going to be talking about simplifying radicals, adding and subtracting radicals, and multiplying radicals. We're going to start off by doing a little warm-up, and you're going to list out your first 15 perfect squares. So I'm going to start you off with 1, 2 squared would be 4, 3 squared would give you 9, 4 squared would give you 16. So go ahead and pause your video and list out the rest of your perfect squares, and when you're ready you can push play again. Alright, go ahead and check your perfect squares and make sure that you got them all correct. And if so, we're going to be ready to move on to our first couple examples. One of the things that you want to think about as we're simplifying radicals here is that you have a principal square root, which is the positive root only. But remember that the square root of a number could be positive or negative, especially if you're solving. So as we get into later on in the unit solving equations with radicals, you'll notice that a lot of our answers we're going to remember to put positive and negative with. We're going to start by simplifying. If you notice, A and B, we have the square root of 45 and the square root of 72. Neither one of those are perfect squares, but they do have perfect square factors. So what I'm going to do is I'm going to write down the factors of 45, one of which is a perfect square, and that would be 9 times 5. 9 is a perfect square, so I'm actually going to take the square root of 9, which is 3, and that's going to come on the outside of my radical because I'm performing the operation of taking the square root. My final answer for this is going to be 3 radical 5. All right, let's try 72. 72, biggest perfect square. Yes, I know a lot of you are thinking 9 times 8, but 9 times 8 is actually more work. We're going to go right to the largest perfect square factor, which happens to be 36. So we're going to do 36 times 2. All right. Now, square root of 36, that's my perfect square. So that's going to come out as 6. So that's going to give us a final answer of 6 radical 2. So some of you may be thinking, well, why can't I do 9 times 8? Because 9 times 8 is 72, and 9 is a perfect square. So let's see what happens. If I do 9 times 8, the square root of 9 is 3. So now I'm at a point where I have 3 radical 8. Well, the square root of 8 still has a perfect square factor, so this is not completely simplified. I can change 8 into 4 times 2. When I have a number that's already outside my radical and I take the square root, I need to multiply those two numbers together. So when I write my final answer, it's going to be 6 radical 2. So either way is going to get you to the correct answer. The one thing you want to keep in mind is if you want to save yourself a little bit of work, try looking for the biggest square factor to start. Alright, I think you're ready to try some on your own. Go ahead and pause the video, do A and B, and when you're ready to check your answers, you can go and start your video again and check them. Alright, if you'll notice, you should have 2 radical 34 and 7 radical 3. So now let's get into using some variables. If you'll notice, you have the square root of x to the 4th. One thing I want you to keep in mind is when you multiply using like bases, you add exponents. When I'm working with variables, I could simplify this into x squared times x squared because 2 plus 2 gives me 4. X squared happens to be a perfect square because I can multiply x by itself. So what happens is this is a perfect square, that's x, but this is also a perfect square, so that's also x. So on the outside of my radical, I've got x times x. So the square root of x to the 4th, because it's a perfect square variable, is just going to be x squared. How about x to the 10th? Well, remember, when you multiply like bases, you add your exponents. So x to the 10th happens to be also a perfect square variable. The answer to that is just going to be x to the 5th. But how about the 15th? I can't multiply a variable by itself and have the exponents be the same and have it add up to 15. So I'm going to show you a little way that you can determine what goes inside and outside of your radical when you're simplifying. On the outside here of the radical, sometimes you'll have a number, sometimes you won't. In a square root, the index is 2. So the index happens to be the number, for example, if you look over here in D, 3 is the index. Okay, so for a square root, the index is 2. You won't see the 2 written there, though. You have to know that that is the index value. So you're going to take, and you are going to take the exponent, and you are going to divide it by the index value. So in this case, I'm going to do 2 into 15. Well, 2 goes into 15 7 times. Multiply that, that's 14. Subtract, we got 1 left over. So here's how you write this in simplified form. Whatever number is up on top here, however many times the exponent went into, or the index went into the exponent, that goes on the outside of your radical. So you have x to the 7th on the outside. Whatever your remainder was goes on the inside. So this would just be x to the 1st. So our final answer is x to the 7th times the square root of x to the 1st. All right, let's try D. 3 into 20. So 3 goes into 20 6 times. So that's 18. Subtract, we got 2 left over. So on the outside of the radical is going to go x to the 6th. Now keep in mind, our index was 3, so I have the cubed root of x squared left over. All right, we've done numbers, we've done variables. Let's do numbers and variables all together. If you'll notice, 225 and x to the 8th are both perfect squares. So since both of these are perfect squares, this is going to be pretty easy to simplify. What's the square root of 225? Good job, 15. What's the square root of x to the 8th? Nice, x to the 4th. So if I simplify that, I just get 15 x to the 4th. All right, let's do B. Both of these are both perfect squares again. What's the square root? Now, if I wanted to, I could simplify this. I can do the square root of the numerator and the square root of the denominator. That's a rule that you're allowed to separate those. What's the square root of m squared? Nice job, m. Square root of 100? That's right, 10. Way to go, you guys are doing great. All right, so those last two examples were pretty easy and you did a great job on them. But let's try this one now where we have to simplify different parts. I'm going to break this radical up into the square root of 12. I'm going to break it up into the square root of x to the 9th. And I'm going to break it up into the square root of y to the 14th. And I'm going to treat each one separately, and then I'm going to put them all back together again when I give my final answer. So this, I can simplify into 4 times 3. Square root of 4 is, oh guys, I apologize for that line there. All right, I got rid of that line for you. Square root of 4 is 2. So this part simplifies into 2 radical 3. All right, now we're going to do x to the 9th. So remember, 2 goes into 9 4 times, so x to the 4th goes on the outside. I have a remainder of 1, so x to the 1st goes on the inside. If I simplify y to the 14th, that happens to be a perfect square. That's just y to the 7th. Now, I'm going to take all those pieces together, and I'm going to make them into my final answer. I'm going to take a look at all of the things that I have on the outside of my radical. The 2, the x to the 4th, and the y to the 7th. That's all on the outside of my radical now. On the inside of my radical, I just have a 3 and an x. So my final answer is 2x to the 4th, y to the 7th, times radical 3x. All right, I think you guys are ready to try one on your own. Go ahead and do B, and when you're ready, you can join me again. All right, how'd you do on B? Pretty good? I'm sure you did. You guys are doing great. All right, let's get into some cube roots. So we're going to start off by listing our first perfect cubes. So if I'm talking about a cubed root, it's something multiplied by itself 3 times. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So that would be 5. Now, if I did 6 raised to the third power, what would that give me? 216. Good job. All right, so there's our first 6 perfect cubes. And now perfect cubes are going to take a little bit more thinking in order to simplify. So let's take a look at A. I'm going to take the cubed root of 64 p to the 12th. Now, 64 happens to be on our list. So the cubed root of 64 is 4. How about the cubed root of p to the 12th? So remember back when I told you to take your exponent, divide it by your index? P to the 12th happens to be a perfect cube. It's p to the 4th. Making our final answer, 4p to the 4th. Now, the nice thing about cubes can be positive or negative. So I can take the cubed root of a negative number, unlike the fact that I can't take the square root of a negative number. So 27 is on our list. The cubed root of negative 27 is negative 3. All right, now we're going to do the cubed root of m to the 6th, and we're going to do the cubed root of n to the 18th. Now, those happen to be perfect cubes. They all divide nicely there. So this becomes m squared. This becomes m to the 6th. Oh, yes, I know, I made a mistake. You guys caught me. That should be an n. It's a good thing you guys pay attention during my videos as well. Alright, so now our final answer is negative 3 m squared n to the 6th. Okay. Before you start these on your own, list out your perfect cubes across the top of your paper because it'll help you in order to simplify. Join me when you're ready. All right, now that you had 2 to try on your own, how did you do? I'm sure you guys did great. All right, now that we've got the simplifying piece down, let's start adding and subtracting. So one of the things that you want to keep in mind as you're adding and subtracting radicals is that your radicals have to be the same. The number inside that radical has got to be the same in order for you to combine them. So in example A, it says negative 3 times the square root of 5 minus 4 square roots of 5. If you can, think negative 3x minus 4x. If I asked you to combine those like terms, you'd tell me the answer was negative 7x. You're using that same concept when it comes time for radicals. So if I want to take negative 3 radical 5 and subtract negative 4 radical 5, I'm looking at negative 7 radical 5 for an answer. Just remember, keep in mind, you're combining like terms. In B, 18 and 32 are not like terms. So what you want to do here is you want to simplify. So just like we did at the beginning of the notes, you're going to go through and simplify your radicals first. So this one's going to be 9 times 2. And this one's going to be 16 times 2. So this comes out, this is a 3. Remember to multiply those numbers out there. So that's 21 radical 2. This comes out and that's a 4. Remember, multiply. So minus 16 radical 2. All right, now if you'll notice, they're both the same. Well, since they're both the same, now I can subtract them. So if I go ahead and subtract them, I'm going to end up with 5 radical 2 for my final answer. Okay, I think you guys may be able to try one on your own. So go ahead and try A and B, and then come back to the video when you're ready. All right, how'd you do? For 9A, you should have had 33y radical 6, and for part B, you should have had 48 times the square root of 2x. On A, I want you to notice that I made sure that I had like terms in front of my radical as well in order to combine them. So all those things that you've learned along the way about combining like terms, make sure you're still applying them. Now, example C I look at as a challenge question. So if you're feeling up to a little bit of a challenge right now, go ahead and pause your video, do C, and then come back to the video. Otherwise, let's move on. All right, last thing we're going to talk about today is multiplying radicals. Anytime you have radicals that have the same index value, so if they're square roots, the index would be 2 and you wouldn't see it. If they're cubed roots, 3, fourth roots, and so on. You can just multiply whatever's inside the radical together to make a bigger product. So if I want to take 2 radical 3 and multiply it by the square root of 15, I'm going to multiply the coefficients of my radicals. So that would be the 2 and the 1. So that's going to be 2. And then I can just multiply 3 times 15. So that gives me 45. Now, before, I didn't have any perfect square factors to work with. But now I do, because now I can change 45 into 9 times 5. So 9 is going to come out as a 3. Don't forget to multiply those two together. So your final answer becomes 6 radical 5. I can also apply it if I have variables involved also. So I'm going to multiply the 4 and the 5 together, so that's going to give me the 20. And then everything inside the radicals can get multiplied together. So 12 x squared y squared. Now, you're not done yet because you got to make sure, see if there's anything inside that you can now simplify. So I'm going to break down this. The 12 can be broken down into 4 times 3. But if you'll notice, x squared, if you remember from the beginning of the notes, and y squared are both perfect squares. So this is going to come out as a 2, an x is going to come out, and a y is going to come out. So we end up having 40xy times the square root of 3. And that's your final answer. Remember, when we first started this section, I said as long as they have the same index value, you can multiply them together. So notice there's a negative in front of the first one. So that's going to be negative 2. And we're working with cubed roots on this one. You're still just multiplying inside your cubed roots. So you have 54 x to the 7th, y to the 3rd. Remember, when you multiply like bases, you add your exponents. Now remember, we're working with perfect cubes this time because your index is 3. So when you simplify this one, you want to keep in mind your perfect cubes. So negative 2. 54 is not a perfect cube, but I can change it to 27 times 2. And then we have our x to the 7th, which we'll worry about in a minute, and our y cubed. So let's take a look at the perfect cubes in there. We have 27, that's 3. And we also have y cubed. So that's y. So right now we have negative 6y on the outside of our cubed root. And if you think back, how do we simplify the cubed root of x to the 7th? So we might, just because it's been a few examples, let's remember. All right, you're going to do 3 into 7. So 3 goes into 7 twice. That's 6. We got 1 left over. So on the outside of the radical, you're going to have x squared. But then on the inside of the cubed root, you're going to end up with 2x to the 1st. So your final answer being 2x on the inside of the cubed root and negative 6y x squared on the outside. All right, those of you that like your box method to multiply binomials together, this may be a place where that comes into play, and we can talk about that in class. But right now I'm going to work with double distributing here. So I'm going to start off by multiplying the 3 times the 2. So that gives me 6. 3 times 4 radical 5. That's going to be 12 radical 5. Then I have 2 radical 5 times 2, so that's 4 radical 5. And 2 radical 5 times 4 radical 5. So that's going to be 8 times the square root of 25. Now we're going to go through and do a little simplifying here. You have like terms in the middle. So this is 6 plus 16 radical 5. Square root of 25 happens to be a perfect square. That's 5. So at the end here of this expression, I'm going to end up with plus 40. What you'll notice now is you have another set of like terms here. You have 6 and 40, so you can actually put those together as 46 plus 16 square roots of 5. And that's going to be your final answer. You can't combine those. They're not like terms. That's how you leave your answer. All right. Next one. If something is squared, write it out. Write it twice and multiply. All right, I took care of my little technical difficulties there. And I wrote it out twice, so now we're going to go ahead and multiply. So 4 times 4 is going to give me 16. 4 times negative 2 square roots of 3, that's going to be negative 8 radical 3. And I'm going to have another negative 8 radical 3. And at the end, I'm going to have a positive 4 square roots of 9. I've got like terms in the middle. That's negative 16 radical 3. Square root of 9 is a perfect square. So on the end of my expression here, I've got 12, which I can now combine with the 16 at the beginning of my expression. So that's going to give us 28 minus 16 radical 3. Again, those are not like terms. Can't combine them. You got to leave them as is. All right, that's the end of our lesson. You made it. You hung with me for 21 minutes. Great job, guys. Now what I need you to do is go back to our Google Classroom, find the form that corresponds to this video. It'll be posted right below it. It's about 3 questions. You're going to answer them and submit them. When you come into class, you're going to practice some of these questions together in your group. You'll have a chance to ask me questions. And remember, it was fun. This is going to be great. You guys are doing awesome for your first video. And I can't wait to see you guys in class and see you sitting and working and engaging in this.